So hello learners, welcome to the IITM student community channel. Today we will be solving the IITM graded assignments, and subscribe us and join our channel to get full access and all our latest updates. So now let's begin. Where v into v but that belongs to r defined as follows. First is v is equals to r square and x1 and y1 x2 y2 and y1 y2 is equals to x1 y1 minus x2 y2 minus x1 y2 plus 2x2 and y2. And second one is v is equals to a matrix. V is a matrix with 2 into 2 ratio, and a and b is equals to tr of a and b, where tr of m denotes the trace of matrix. Okay, so this one is known as the trace of matrix, and that is the sum of the diagonal elements of m. And the third one is v is a m of it's a matrix of 2 in the form 2 into 1, where a and b is equals to the trace of ab, and where tr of that is trace of x denotes the trace of matrix x, that is the sum of the diagonal elements of x, and y and t denotes the transpose of matrix y. And the fourth one is v is equals to r2, and x1 x2 and y2 and y1 is equals to x1 y2 plus x2 y1. So as few options are given. First is that the option 1 is an inner product, second one is option 2 is inner product, or option 3 is inner product, or option 4 is inner product. So now let's find out which one is inner product. So here we have the solution for the question number 1, that is the recall that this one r is an inner product if first one x and x is greater than or equals to 0 for all this one x belongs to v, where x comma x is equals to 0 if x is 0. Second is x and y is equals to y and x, where x and y belongs to v. Third one is ax plus y and z is equals to alpha into xz plus yz, where x and y and z belongs to v and x belongs to r, it's alpha belongs to r. Then we have our option number 1, which says that v is equals to r2. Then we have x and x2 and y1 and y2 is equals to x1 y1 minus x2 y2 minus x1 y2 plus 2x2 and y2. Then x and y x1 x2 and x1 x2 is equals to x1 square x2 x1 minus x1 x2 plus 2x2 square, where x1 square minus 2x1 x2 plus 2x square. We get it after solving this. Then we have x1 minus, this one is known as x1 and x2 x1 minus x2's whole square. Yeah, this one is in the form of x1 minus x2's whole square plus x2 square. Which one is greater than or equals to 0, where x and x2 belongs to r2. Also we have x1 and x2, and x1 and x2 is greater than or equals to 0. Yeah, it's not 0, it's x1 minus x2 whole square plus x2's whole square, or it's x2 square actually, that is equals to 0. If and only if x1 is equals to x2 is equals to 0. Then we have our x1 x2 y1 y2, it's x1 x2 y1 y2 is equals to x1 y1 minus x2 y2, it's x2 y1 minus x1 y2 plus 2x2 y2. After solving this, we have y1 x1, you may also write it as x1 y1 minus y1 x2 minus y2 x1 plus 2y2 x2, that is equals to this one y1 y2 and x1 x2. And then we have x1 x2 plus y1 y2 and z1 and z2 equals to x1 plus y1, x2 plus y2 and z1 and z2. So we'll solve it as x1 plus y1 into z1 minus x2 plus y2 minus into z1 minus x1 plus y1 into z2 plus 2 into x2 plus y2 into z2. Then we have x1 z1 plus y1 z1 plus x2 z1 minus y2 z1 minus x1 z2 minus y1 z2 plus 2 into x2 z2 plus y2 z2, which is equals to x1 z1 minus x2 z2 minus x1 z2 plus 2x2 and z2 plus y1 z1 minus y2 z1 minus y1 z2 plus 2y2 and z2. Okay, so let me clear this. Then we have, after solving this, we have x1 x2 and z1 z2 plus y1 y2 and z1 z2. Then we have alpha into x1 x2 and y1 y2. So we'll multiply alpha with this. Then we have alpha x1 plus alpha x2. Sorry, there is no sign of plus. Then y1 and y2. So by separating these, we have alpha x1 into y1 plus alpha x2 into y1 minus alpha x1 into y2 plus 2 into alpha x2 into y2. That is equals to alpha into x1 y1 minus x2 y1 minus x1 y2 plus 2x2 y2. Similarly, we have alpha into x1 x2 and y1 y2. Then we have our option number 2. Yeah, for this we have alpha, it's v is equals to m of 2 into 2r, where a and b is equals to trace of a. Then let a is equals to, a will be a matrix in the form of 1 and minus 1 and 1 and 1. Then we have a and a is equals to trace of a square, which is equals to trace of this one into 0 and minus 2. 2 and 0, that is equals to 0, but a is not equals to 0. This contradicts x, and x is equals to 0 if and only if x is equals to 0. Then we have our option number 3, that is v is equals to, v is a matrix in the form of 2 into 1 r, where a and b is equals to trace of ab transpose. Here please note that a belongs to m of 2 into 2, 2 into 1. R is in the form of a1 a2. From a, for a and b belongs to this matrix R, and the transpose of ab, that is ab to the power t, is equals to a1 b1. Yeah, this one a1 b1, a1 b2 and a2 b1 and a2 b2. So thus the trace of this ab transpose will be equals to a1 b1 plus a2 b2. And we can say that a and b is equals to a and b plus a2 and b2. Yeah, here it is, a and b is equals to a1 b1 plus a2 b2. This looks like the standard inner product in R square, and the properties can be similarly verified. So now let's have a look at the option number 4. So here we have v equals to r2, where x1 y x2 and y1 y2 is equals to x1 y plus this one, yeah, it's x2 and y1. For x is equals to 1 and minus 1, where x and x is equals to minus 2, that is not greater than or equals to 0.